So today we are going to see about the operating system concepts. So this topic is particularly useful to know all the concept that is present in the operating system subject, right? So you can have a glance or overview, or whenever you are going for an interview preparation, this will be the most useful slide that you can able to use it, because all the concepts have been covered, and it has been covered in a student oriented approach, because we all love memes, right? So this particular presentation has been illustrated through memes, and it will be very useful to you, right? So let's see. So this will be the particular mind voice by the operating system, right? Because whenever we switch on any system, right, the first component that is going to get operated is the operating system. After once the boot operation has been completed, then the next loading will be the operating system. So this will be the mind voice by the operating system, right? So you know the film Vikram dialogue, Arambikklangla, the same thing, right? So the operating system, it is actually an interface between the software and hardware of the computer. So it is going to act as a communication between the software and hardware of the any particular system, and it provides an environment where the user can execute their applications using the help of the hardware. So this is the illustrated through the memes, which is present in the Friends film, right? That is a particular a common known well joke. An operating system, it acts as an interface. So this particular Radharavi character has been illustrated as hardware, and Charlie has been illustrated as software, and the Vadivelu, who will be the communicator between those hardware and software, right? He is illustrated as an interface. So this operating system acts as an interface between the hardware and software, and it makes them to work compatibly. Second thing is the functions of operating system. The main functionalities of operating system has been given here. The first one is memory management, process management, device, file, security, job processing and accounting, system performance control, error detection, communication between the user and software, and hardware. So here all the same file operations or the operating system functions has been illustrated here. Here we have the file device. We know the popular film Bahubali, right? So in this particular, the scene is so much of hype, and it created hype, and so much of importance is given to the scene. So here you can able to see the operating system, who is going to be the main character in Bahubali, hero Prabhas, right? So I have illustrated that as the operating system, which pulls out all these functions. It may be the processor, memory operations, file, device, security operations, and you know in the last slide, right, he only calls the name, he identifies and calls the name Bahubali. So I have illustrated him as the communication, right? Next, this is the main warning that is given by any operating system. You should not enter into the operating system memory region. That is the main warning given by any operating system. You know remember this particular dialogue, right? In the கோட்டை தாண்டி நீயும் வரக்கூடாது நானும் வரக்கூடாது. That is the actual warning given by operating system. So you should not enter into the operating system memory region. Then that will create a trap to the system, right? That is created by the operating system. And this is how the multiple programs are kept in main memory. In any multitasking system, all the programs will be kept in the main memory, and each program has its own features. It may vary in size, its characteristics are different, but everything is kept in the main memory, and they have been accessed from the main memory for further operations. Kernel, right? So when an operating system is particularly loaded, the first part that is going to get loaded is kernel. So that I have illustrated with the film hero. In this particular scene, the first thing that is get loaded is the iCap, right? Then only the actual men will come on to it. So that is the kernel that I have illustrated through kernel. It loads before any part of the other OS. Next, the monolithic kernel. So this monolithic kernel, it looks similar. The memory space used by the user services and kernel services are similar and same. Whereas the microkernel, it size is actually small. We can able to load only small amount of program in any microkernel, right? User kernel services, they reside in different part of the memory. So that's why I have illustrated through the Apurva Sahodarargal film. In that, Kamal will do a the role of tiny part, right? The same thing is illustrated here. So this is the actual difference between the microkernel and monolithic kernel. So it is a low level address space is provided by the microkernel, whereas the monolithic kernel, it is available in the operating system. The entire operating system workspace is taken there. And the services and kernel services, operating system and kernel services separated, whereas the kernel contains the operating system services. And comparatively, microkernel is slow, whereas monolithic is fast. Next, the demand paging. So it is the main concept used, or the virtual machine works with the main concept of demand paging. So the actual concept of demand paging is only the part of the process that needs to be present in the main memory have to be available in the main memory, and all other will be residing in the secondary memory, right? Whenever there is a demand for a particular page or a segment of memory, then that is swapped in to the main memory or brought in from the secondary to main memory, and that will be executed. There is no need for keeping the entire process or the entire part of the memory into the main memory, because it can save more space so that other process needed part may be kept in the main memory, right? So this is how we can able to save the main memory. So this is the most particular operations that we are going to do, swap in and swap out between the main and secondary memory. So whenever we are moving any page from main memory to secondary memory, then that is what we call it as a swap in, and from secondary to main we call it as swap out. Virtual memory, right? So it will create an illusion that we are having a very big main memory, but actually it is not. We will have what we have, right? So whatever the memory configurations we have physically, that is the actual what we are owning it. But it creates an illusion. That's what I said, because it uses the concept of demand paging, and it creates that there is a large amount of memory spaces present over there, right? So this I have illustrated with the example with the cricket. So actually what we can able to see, the physical memory is actual bowling team, where everyone in the team has to be present in the field. Whereas the virtual memory, it looks like a batting team, only who are playing currently, right? The one who's in the strike and the runner who is in the opposite side will be available in the field, others will be in the outside of the field, right? So that is how I illustrated the virtual memory here. And also we can able to remember the famous dialogue, right? Irukku ana illa. So it is the main concept of virtual memory. And the system call. So whenever OS wants to communicate anything, or we need to communicate something with the OS, the main thing that we can able to do, or with the help of system call only, we can able to communicate with the operating system. So there will be two modes, user mode and kernel mode. Whenever we want to switch from user mode to kernel mode, we can be done with the help of a system call. So this is the actual operating procedure. The user process getting executed, it is executing a system call. Automatically the mode will be converted from user mode to kernel mode. So in the kernel mode only we can able to execute the system call. Once the operating system completes its operation, then we can return to the user mode, right? That is, they have illustrated as return from system call. So this is the actual real-time example which is happening in each and every house, right? You can be a king outside, but when you return home, then you have to face these consequences from your wife. Your wife is the boss. So I have illustrated the wife as the system call here. And process, so which is the unit of execution, which is currently being done, right? And thread, the difference between the process and thread is the process, for each process we need to create a separate memory. The separate memory has to be created for each and every process, but thread, it shares the memory of the process. So one process can contain n number of threads, and all the threads will share the same memory allotted for that particular process. And the critical section, yes. So once you have brought a catchy lunch, right, then what will happen in the lunch time? Suppose if it is going to be a buri or a biryani like that, what will happen? Then your tiffin boxes, it will have n number of hands inside. The same thing as critical section, right? That is a shared region which is accessed by n number of process. And the race condition, yes, the output of any operation depends upon the order of execution. So we can able to have the famous dialogue from Pokiri, right? எதையும் பிளான் பண்ணாமல் பண்ணக்கூடாது. The same dialogue suits the race condition best. And thrashing. So CPU, it will waste most of the time without executing, just because of context switching from one process to another process without doing any useful work. So automatically the CPU efficiency will be decremented, right? It will always decline. So it is illustrated with the famous dialogue, right? What is the dialogue here? அந்த மூட்டை குடோன்லேயே இருந்திருக்கலாம். The same thing, right? Then mutual exclusion, right? Once you get a lock into the critical section, only one person can enter into the critical section and no others can enter it. They have to wait for the their turn. Deadlock. So it is a situation where a set of processes are blocked. Why they are blocked? Because their resources are utilized by something, some other process. So they have to wait for that resources to be freed by that process. Then only they can able to enter. Similarly, they are executing some other resource which is needed by another process. So no one can execute further. There will be no progress, right? So that is what the famous dialogue tells about. எந்த பக்கம் போனாலும் கேட் போடுறாங்களே. Or else you can have the big boss dialogue. ஓடவும் முடியாது, ஒளியவும் முடியாது. See, you cannot go in any direction. There will not be any progress. And non-preemptive scheduling, right? So even though whatever the process have high priority, it will not be considered in case of non-preemptive scheduling. All the process will be treated as same. So that's what I illustrated with a slide here, right? So there are this has been known in a voting system, right? So this we have seen while casting the vote. Popular actor Ajit cast his vote by standing in the proper line with the public, right? So that is an example for non-preemptive. Whereas the preemptive scheduling, the VIP card, where you own, the purpose of the card is you will be given the special importance or priority. That applies to the preemptive scheduling also. So if a high priority process arrives, then we need to stop the execution of the low priority and the control has to be given to the high priority process. Next, the starvation, right? So whenever the low priority process is always getting preempted because of the arrival of new high priority process, then automatically what will happen? The low priority has to wait indefinitely. Then that stage is what we call it as starvation, right? So that is illustrated here with an good dialogue, right? I don't know the film name, I didn't remember, but the dialogue is Yelavu Kathakili. It won't get a chance. Next, semaphore. Usually we will see in the railway crossing signals, right? So it is a tool for the critical section. It is a semaphore, it is a tool for synchronization. So it has mainly two operations, wait and signal. And the bounded buffer problem, right? So it is a classic example of a synchronization problem. It allows multiple producers and multiple consumers to share a single buffer. Whereas we have two components, one is producer and another one is consumer, where the producers can able to write the data to the buffer and consumers can able to read the data from the buffer. So this is shown with a popular scene, right? In that Vadivelu will steal some amount of rice from each of the rice shops, right? So there they want to maintain the synchronous. They have to work in synchronous, right? Once the shop owner has been on the other side, they have to take the rice. So that is well illustrated with that example. Next, readers writers problem. So here n number of readers can read any file at a particular point of time. That doesn't affect the data. But once the writer enters, then we cannot allow n number of readers or more than one reader to write at the same time. Then that will affect the integrity of the particular data, right? So the data will not be consistent. So we need to take care of this, and that has been helped with the case of synchronization, readers writers problem. So if a writer is going to enter into the critical section, then they have to imply a lock. then they have to have a lock, then they can enter into the critical section, they can write the data, and if some other writers are ready to write, they have to wait for the lock, right? So that is what illustrated here. So this is the best example seen from Winner, right, where Prashant will enter into their hometown and he will be greeted warmly by his grandma, ரைட் ஆரத்தி எடுக்கிறேன்னு சொல்லுவாங்க இல்லையா. ஸோ பிரசாந்துக்கு எடுத்துகிட்டு, ஸோ ரீடர் ஒன் ரெண்டுமே ரீடராக இருந்தால் பிரச்சனை இல்லை, எல்லாத்துக்குமே எடுக்கலாம். பட் ஒன்ஸ் அ ரைட்டர் enters, what will happen? Another writer is already there, then the writer 2 will not be allowed to enter into the critical section. So that is invalid. And dining philosopher's problem. Here there will be n number of philosophers who will be waiting for the waiting to have their lunch, and there will be the dining table which is in a round shape, and they have their forks with them, and a particular philosopher can start eat only when they have their two chopsticks, or when they have their left and right forks, right? Then only they can able to eat, otherwise they cannot able to eat. So that is what illustrated here. So once they have acquired the left chopstick, but the right chopstick is available with some other user, then both have to put down the chopsticks and wait for another turn. So this is given with a easy scene where the dialogue is மறுபடியும் அன்னைக்கு காலையிலேருந்து 6 மணிலேருந்து ஆரம்பிப்பாங்க. The same thing happens in dining philosopher's problem. Then swapping. The swap out and swap in from main memory to secondary memory, what we have seen in virtual memory, right? So that is illustrated here with the popular film Thillumulu, where single character will play a dual role, right? So they will confiscate at last, right, that there is only one person, but he has been doing the fraud things all over the film. So that is what here. And fragmentation, right? So the amount of free space that is available in the main memory, that is what we call it as a fragmentation, right? So this fragmentation is always an unused space some cases, because we cannot utilize it for any of the available process. That is what we call it as the wasted. So அதுக்கு தான் அந்த நம்ம அந்த ஃப்ரெண்ட்ஸ் படத்துலேருந்து அகெயின் வடிவேலு சொல்லுவார் இல்லையா, எந்த வேலையும் செய்யாமல் இருக்கிறது தான் உன் வேலை அப்படின்னு, அந்த டைலாக் எக்ஸாக்டாக மேட்ச் ஆகும்.